Welcome to everybody. Welcome to my YouTube channel, MathLab. Okay. Today we're going to talk about the solution to the GC June 2023 Pure Math Statistics, Paper 2. We are going to get started with question 3. So the question reads: a function is f is defined on R by f of x equals to 3x over 5x minus 2. A. State the domain of f. Show that if f is B, injective, C, monotone decreasing. Roman 2. Find the range of real values of the function y equals to 3x squared all over 4x minus 1 for x element of R, x different from 1 over 4. Okay, so with that, I just get started with the solution. Okay, I just start with the first part. We have a function R. Okay, a function defined on R where f of x equals to 3x over 5x minus 2. The A part say find a domain. To find the domain of a function, we just need to find the set of values in which the function is valid. Okay, so for this function to be valid, you can use all real numbers except 2 over 5, because if you replace x by 2 over 5, you see that the function down here will become 0. So you have 3x over 0, which is undefined. Okay, so in this particular, to find a domain, you just need to look for that value of x that will make the function to not work. Okay, once you get that value, you now put it in your range. So you're excluding 2 over 5 in your range. Okay, for all your real values except 2 over 5. That's why there's a negative sign in front here. Okay, it's for the exception. So now we are going to show now that the function is injective. So to show that the function is injective, we say what? We take any value, okay, for all values of a and b, element of R, excluding what? 2 over 5, as we know that is a domain, so 2 over 5 will not work. So for all values of a and b, it's an element of real numbers except this, we need to show that f of a equals to f of b. So that is a relationship we need to have for f of x to be injective. So with that now, we have that 3a. So everywhere we have x in our function, we replace it by a. So we get this 3a all over 5a minus 2 equals to 3b over 5b minus 2. For a and b, that is f of a must be equal to f of b. We now cross multiply and we simplify. If you cross multiply this, you're going to get what? 15ab minus 6a on this first side for 3a times 5b minus 2a equals to 15ab minus 6b for 5ab minus 2 times 3b. So now this will imply that what you simplify, you see that this 15 here will cancel with this other one. If they come to the other side, you'll be 15ab minus 15ab. You're going to get 0. So you're left with what? Negative 6a minus negative 6b implying that what? If you simplify both sides by negative 6, you're going to get what? A equals to b. Okay, so how do we conclude now? We say, so for f of a equals to f of b, where a equals to b, hence f is injective. Okay, so for f of a equals to f of b, that is for any value of the function of x, okay, equals to another any value replacing the function, you're going to get a equals to b. That is, that value will be equals to the other chosen value. Okay, so that is it for the injective function. Now with that, now let us verify whether the function is monotone decreasing. Okay, so to do that, we first of all start by differentiating our function. Okay, so to differentiate here, we're going to use the substitution u equals to 3x. Okay, so we let u to be equals to 3x and we let v to be equals to 5x minus 2. From the quotient rule, that is x prime of x equals to v du dx minus u dv du dx all over v squared. Okay, so with that, now you replace the value of v. Du dx is just the differential of u with respect to x. You do that, you say minus u dv dx, you differentiate v, you're going to get this all over v squared, where v is 5x minus 2. So in other way, in other way, we can just say, to have this the differential here, you just say is bottom the top minus top the bottom all over bottom squared. Okay, so that is it for the function. So you can say what? Bottom the top minus top the bottom all over bottom squared. So you get that, you simplify now, and you're going to get negative 6 over 5x minus 2 other squared. Now to verify if this function is monotonically increasing or decreasing, we just need to verify that if we take any value of x, will it be more than or less than 0? In this case, yes, since we have already a negative 6 up in the function, automatically for all values of x, excluding 2 over 5 as we know, f of x will be monotonic decreasing. So that's how we have verified. So we have that negative 6 over 5x minus 2 other squared is less than 0. The answer will always be less than 0. You can replace any value. Okay, let's take for example 1. 5 times 1 minus 2 is 3. 3 squared is 9. 6 over 9, you simplify, you're going to get a negative number. Okay, and the negative number is less than 0. So that is it. So hence for all x element of the real numbers, element of that is real for except 2 over 5, we have that f is monotone decreasing. Okay, so with that, now let us now pass to the Roman 2 part. So we are asked to find a range of real values of the function y equals to 3x squared over 4x minus 1. Okay, for all elements equals to, we are going to find the range of real values of y equals to 3x squared all over 4x minus 1. Okay, with that, we first of all start by multiplying all through by y. So we cross multiply. In fact, because multiplying, we make this equation to resemble a quadratic. Okay, so you're going to get this 3x squared minus 4xy plus y equals to 0. So this resembles a quadratic in terms of x. Okay, in terms of x and y. Okay, now with that, now we can now use b squared minus 4ac, because we now need to make this function to resemble, to be only in terms of y, this quadratic. So using b squared minus 4ac greater than or equals to 0, this will imply that what? Negative 4 y squared, the value of b, okay, minus 4 into a c, c is y, okay, is less than or equals to 0. You open the bracket, you simplify, and we're going to get 16y squared minus 12y. With that, now this implies that what? This implies that 4y, we factor out 4y, okay, simplify further, we factor out 4y, and we're going to get 4y equals to 4y minus 3 less than or equals to 0. So now we let this function now to be equals to 0 to get different values of y. Okay, so if you let this one to be equals to 0, you're going to get y to be either equals to 0 or 3 over 4. Okay, so with that, now we now produce a number line to see now where the function will work, because we are asked to find a range of real values for which the function y is real. Okay, for it to function, for it to be normal, for it to make sense. Okay, so now we replace our values of y, 0 and 3 over 4. We now verify. We take a value less than 0, negative 1. We replace in our function, this function here. And we verify if the value is greater than or equals to 0. If it is greater than or equal to 0, then the function works for all values less than 0. Now we take a value between 0 and 3 over 4. We take any value that is 0.5. You replace it here. Replacing your function, you verify if the answer is greater or equal to 0. For this case, it does not work. Okay, so you're going to have this negative because it does not work in that region. We are not going to take that region. Now we take any value greater than or equals to 3 over 4. Any value greater than that, we can have 1. We take even 1. We replace 1 here. You're going to have, if you replace 1 here, you're going to have 4 into 1 into 4 times 1 minus 3. So you're going to get about 4 minus 3, which is 1, times 4, which is 4. So 4 is greater than or equals to 0, so it works. Okay, then with that now we now just input the, we now give now the range of real values. Okay, so we do that by saying what? We do that by saying that y is less than or equal to 0, or y is greater than or equal to 3 over 4 from our number line. That's what we have gotten. Okay, so y will be real or will work below 0, and will also work above 3 over 4. So that is what we get. So that is all for the solution of this particular June. Okay, so I thank you all guys for watching. Please like, comment, and subscribe to my YouTube channel MathLab. Okay, the future is very, very wide and more is to come. Okay, so I thank you all. See you in another video.